Welcome back to Physics with Miyoshi. We're going to do a second law problem again. And this one's a vector problem. And so let's get to it here. We're going to find the acceleration if we have a man paddling on a raft and the wind is also acting on this raft. The two of them together, the raft and the man, they're acting as one body. So their total mass is 13 kilograms and the wind is acting with a force of 15 newtons. It's accelerating the raft and also the man paddling. And notice my beautiful picture there of the raft and the overhead view of the man's head and the paddle in the arms. Don't you love that? Anyway, he's paddling and he's got he's affecting it at 17 newtons due east. So we're going to figure out, and the wind is acting at an angle of 67 degrees north of east. So we're going to figure out exactly what his total force would be. Well, actually, we're just going to figure out the components, and then we'll figure out the total acceleration afterwards. So if we break up just the wind, if we take the wind, since we know the paddling is going only in one direction, we're going to just take the wind and we're going to break it up, knowing, I'm going to draw this little picture here. My total force is equal to the components. Remember, I start from the beginning, the same place at the beginning, and I put the tail to the head, and a tail to my head to get this would give my result. So the x wind component and the y wind component add up to get my total wind component of 15 newtons. So if I look at this, I always draw the picture because I don't know whether my x or my y is going to be cosine or tangent. In this case, my cosine theta is my x component divided by my total wind component, and sine theta is my y component divided by my total component. So rearranging this equation here, I get my wind component in the x direction is my total wind component times cosine theta. So I'll plug those numbers in and I get 5.86 newtons. Okay, I like to actually do all my math here so I can see where I might have made my mistake. I just got rid of my 6. And I do the same thing for my sine. I'll try to face you all. Sine theta is my my wind component in the y direction divided by my total wind component. And so that's 15 newtons times the sine of 67 degrees. And we can see again opposite over hypotenuse for sine. That's going to give me 13.81 newtons in the y direction. Now, I'm going to rearrange my free body diagram. And here's my wind in the x direction, and here's my paddle force. And so my total force in the x direction is going to be the paddling plus the wind in the x direction. So I add those together. My paddling force again from back here was 17 newtons. I add it to the x component of my wind, and I'll get 17 plus 5.86 newtons. It's going to give me 22.86 newtons in the x direction. In the y direction, there's no other components besides the wind, so I'll just have 13.81 newtons. And then all I have to do to find the acceleration in both directions is going to be take my total force divided by my total mass. And in the x direction, again, it's 22.86 newtons. I'll break the newtons into kilogram meter per second squared and divide that by 1300 newtons or kilograms and get 0.0176 meter per second squared. In the y direction, again, I divide the 13.81 kilogram meter per second, which is a second squared, which is a newton. Divide that by 1300 newtons or kilograms, and my kilograms divide out, and I get 0.0106 meter per second squared for my acceleration. I always try to check my units so I can make sure that the units match up with what I'm trying to find. In this case, when my kilograms drop out, I have meter per second squared left, and that I know is a unit of acceleration. Now, there's one last thing I'd like to do and show you how to do, and it's just kind of a reminder of vectors, and that is, let's take this guy now and not just find the components, but let's find the total acceleration vector. Okay? So that's just an application of Pythagorean theorem on a limited trig, and so I have my acceleration total is going to be, well, let's just find the magnitude. My a squared is going to be ax squared plus ay squared, just from the Pythagorean theorem. Again, this is going to be, let's just draw my force total, if you will. And my the angle for my acceleration will be the same. So if I draw my free body diagram with acceleration, it should look something like this, where this is my theta, this is my ay and my ax, and this is my total acceleration. So now all I have to do is plug those guys in, and my ax was 0.0176 meter per second squared, and I'm going to square that, add on to there 0.01006 meter per second squared, add those together, and I get something like 0.000422 meters squared per second to the fourth. And so A, the magnitude, is square root of that guy, which happens to be 0.0205 meter per second squared. Then to find the angle, I will just take the arctangent again, so I know from this figure here that my tangent theta is ay divided by ax. So let's look at that. Let's put that in there to my equation. Tan theta is ay over ax. Ay is 0.0106 meter per second squared. Divide that by 0.0. Oopsie, did I do that wrong? Sorry, that's wrong. Oh no, that's right. 176 meter per second squared. Is that right? That's my x, that's my y, that's my y, that's my x. And then my meter per second squared gets taken away there. So this tangent theta is, what is it? 0.603. The units go away, which is perfect. So now I know that theta is the arctangent of 0.603, which is 31.13 degrees. And if I look at my picture, this is the east direction. It's north of east, so that would be north of east. So my total acceleration vector is the magnitude 0.0205 meter per second squared at 31.13 degrees north of east. So it's a little bit longer process to find the vectors, but I think it's well worth the effort. After all, we've spent all that time doing vectors before, so we want to go ahead and continue to do that. But this is the application of Newton's second law to a two-dimensional example where we have forces in two directions acting on an object, and we find that we can find our acceleration by knowing our total forces and dividing that by our total masses, adding it all vectorially, and coming up with our solution. So, thanks for tuning in and doing another problem with me for Newton's second law, and hope you enjoyed it. Hope you're learning something, and hope you tune in again next time for more physics with Miyoshi.